Okay, this is video 3 for chapter 11, and this video is appropriate for both college prep chemistry and honors chemistry. In video 3, we're going to be focused on the heating curve. So far, before this video, we've learned Q equals MCAT. So you have this trick. And you've also learned thermochemical equations. In this section, we're going to take those two and kind of put them together. So we have those two skills coming into this video. So what we're going to do is a heating curve. Looks like this. And on the x-axis, we use heat, which we've learned is usually joules or calories, the two most common. And on the y-axis will be temperature, which we usually measure in Celsius or Kelvin. We never use the F word in this class. So, the curve looks like this. You're going to notice there's no curve to the heating curve. It is a slanted line, a flat line, a slanted line, a flat line, and another slanted line. The lengths of these lines and the degree of the slant all depend on the substance. So this is just a general graph. In this first slanted region is where you'll find your solid substance. And if you have a solid here, if you add heat, you go to the right, it will slowly increase in temperature. But there will reach a point where even though you continue to add heat, the temperature doesn't change. And this is during the phase change. So just so you can know what I'm saying, phase change. So a phase change is occurring here. In this case, we're changing from solid to liquid. And in the phase change, we want to look up the heat of fusion. How much heat does it take to melt? That's what the heat of fusion is telling me. Once you're past the liquid, so we add heat, the solid gets warmer, then the solid will melt, then the solid will turn into liquid, and the liquid, as you add heat, will go up in temperature. The liquid will then change from liquid to gas, and the liquid to gas area, you would need to look up the heat of vaporization. Should have made my line longer. So these are pretty much the 5 regions. So you need to be able to label solid, liquid, gas, heat of fusion, heat of vaporization. Okay? Now, the opposite of heat of fusion, if we're going this way, so heat of fusion is if we're going that way. If we're going this way, the opposite of heat of fusion, the opposite would be solidification. But here's the trick. Heat of fusion is equal and opposite to the heat of solidification. So usually you just look one up, okay? The other one, heat of vaporization, is if we're going from liquid to gas. The opposite process, going from gas to liquid, would be the heat of condensation. And same thing, the heat of vaporization is equal and opposite to the heat of condensation. Okay, so in the problems, you're going to be given a substance somewhere on this graph, and you'll be asked to change that substance to a different region of the graph. If you are given something in a slanted region, any of those slanted regions, then you're going to use the equation Q equals MC delta T. If you're given a substance in the dimensional analysis region or the flat regions, then you have to use dimensional analysis. So for instance, if you were given a substance at this temperature and you're going to change it to here, you would just use Q equals MCAT. If you're given a substance here and you had to change it to here, you would have to use Q equals MCAT and dimensional analysis. So that's why we want to have both of those in the back of our mind. Okay? Let's try some problems. And I think I forgot to point this out, so let me point it out. You need to make sure that you have page 308 and 296 accessible so we can look things up. 308 and 296. Okay. The first example, go ahead and copy it down. Okay. In this example, it says how many grams of ice at 0 degrees and 101.3 kilopascals, that's just part of the story if you want to go do this at home, could be melted by the addition of 0.4 kilojoules of heat. Huh, interesting. So what I would encourage you to do is to always sketch this. Sketch it. Got heat and temperature. How many grams of ice? Ice, solid, at 0 degrees. What temperature is there? That's ice right there. Can be melted. So I'm in this zone right here. I'm taking a solid and I'm melting it. So what do I need to do? I need to do dimensional analysis. There's some things I need to look up. In this zone, we need heat of fusion. So I need to look that up. So heat of fusion, make sure you look it up for water. And I'm looking it up as you are looking it up. And we are both going to be looking on page 308. And I'll show you my book. You can't really see the numbers, but here's my substance going down to water, going over to the heat of fusion, 6.01 kilojoules per mole. So let's write that down, 6.01 kilojoules per mole. Well, that's not bad. That's a good start. The next thing, so I need to use dimensional analysis. I want to know grams, and I have that much heat. This is very similar to chapter, I'm trying to remember, 7, chapter 9. Kilojoules to grams. I can do kilojoules to moles. Moles to grams. I think to myself, moles to grams on my molar roadmap. That was from the periodic table. So the formula for water is H2O. So that's 1 plus 1 plus 16. This is all happening in my brain. I came up with 18. Hopefully we got the same number. Look how lazy I was, 2 sig figs. So my answer gets 2 sig figs, so I'm going to work this one out. Let's see, 0.4. Well, that was genius. I calculated wrong. With 2 sig figs, I get 12 grams. Put a box around your final answer. So that was it. So we probably could have done this before, it's just that there's a lot of extra information. Let's try another one. The next problem says this. How many kilojoules of heat are required to melt 10 gram popsicle at 0 degrees and 101.3 kilopascals? That's just there to confuse you. Assume the popsicles have the same molar mass and heat capacity of water. So we're pretty much saying popsicles are water. We already knew that. So I have 10 grams of popsicle at 0. Something I maybe didn't mention before. What temperature does water melt at? 0. So that's going to correspond with that flat line. What temperature does water boil at? 100 Celsius. So that'll correspond with that line. Let's say you don't know when things will boil or freeze. On page 308 it tells you their freezing points and their boiling points. So you can look them up. We spend a lot of time with water and we know water, so we just don't even look it up. Okay, so I'm frozen at 0, so frozen at 0. How many kilojoules to melt it? So all I want to do is get to there. Very similar to the previous problem. Go ahead and do it on your own if you can. Pause here if you can and do it. Two sig figs, because guess what? I was lazy again. I just went with 18 grams. Okay? So this is really the same as the last one. Let's try something slightly different. How much heat in kilojoules is absorbed when 63.7 grams of water at 100 is converted to steam at 100? Draw your heating curve and label the area you're going to be working in. Okay, heat of vaporization, I'm looking it up, showing you everything I'm doing. Nothing exciting going on here. 40.7 kilojoules per mole. And it asks for it in kilojoules, so I'm going to be careful and stick with kilojoules. What am I starting with? I have that many grams of water. And I know kilojoules per mole. So I'm going to change my grams of water to moles of water. You could probably hear my daughter, and I apologize, she's talking. I told her to be quiet. This is her being quiet. I left with kilojoules. Look, that's what I even wanted. So let's calculate it. I'm doing 2 sig figs again because of my problem there. So far everything's one bit. Okay? Let's try some more. How many kilojoules of heat are absorbed when 0.46 grams of chloroethane vaporizes at its boiling point? And the molar heat of vaporization of chloroethane is this. So it gave me everything. Look, it boils at 12 degrees Celsius, nice and cool. So same graph, different compounds, same graph. Temperature, heat, vaporizes. So it's in this region again. It's just not water now. You should be doing this on your own. When I go quiet, you're working quietly too. Down here, I'm going to figure out my molar mass for this guy. 2 times 12 plus 5 times 1 plus 35.5 equals, could have done it in my head, but I'd mess it up. Grams per mole. So I have 64.5 grams in 1 mole of that big ugly thing. Whew, what a molecule. I now have moles, I want kilojoules. The heat of vaporization is this. So it is just 26.4 kilojoules in 1 mole. And that's it. .118 is your answer on that one. Make sure yours matches mine, and that we're good. I'm going to do one more problem with you, just like I would during class. Sometimes I realize, I just didn't quite represent everything. So let's do how much heat to take 12 grams of water, let's do at 25 degrees Celsius, to steam at 100 degrees Celsius. So how much heat, that's going to be my question, to take 12 grams of water at 25 degrees to steam at 100. So let's try this one. I'm going to have temperature, heat again. So 12 grams of water at 25 degrees. Well, this is solid, this is liquid, so it's in this zone somewhere at 25 degrees all the way to steam. So I have to heat it up and then vaporize it. So I'm going to do 2 things. The first thing I'm going to do is I have to heat up my water. This is what you do on the stove. You heat it up and then you make it boil. And hopefully before it all boils away you add pasta, but if you are texting and lose track of time, then you missed it. So this has 2 parts. So let's do the green part first. The green part, the slanted part, I said is Q equals MC delta T. And then the flat part is going to be dimensional analysis. So there it goes. So 2 problems. First part, Q equals MC delta T. How much heat? Well, how many grams of water? The mass of water. I look up the specific heat capacity of water. I also memorized it, and you're memorizing it too, right? Oh yeah. And then change in temperature. In this region, the final temperature, at what temperature did it stop heating up and went through phase change? Or what is its boiling point? 100. So final minus initial. So the heat required just to heat up my water, not to boil it, I should show you, times 12 is 2 sig figs, so 3800 What are my units left? Let's look again. Grams, grams, Celsius, Celsius. Whew, I'm left over with joules. So 3,800 joules to heat up my water. Okay, now I'm not done. I got my water heated, now I want it to vaporize. This region right here, we're going to use dimensional analysis. How much heat? Well, I'm starting with 12 grams of water. And I know 18 grams of water goes to 1 mole of water. In this region, I need to look up the heat of vaporization for water. And I already looked it up before, and it was 40.7 kilojoules per mole. So we're going to do this 40.7 kilojoules in 1 mole. And my units count. Okay, I think the video cut me off, so I'm going to try and piece this together, but it might just be horrible. Sorry. So we were somewhere in dimensional analysis when the video ran out of space, and I deleted my Big Bang Theory for you off my iPad. Okay, so 12, I'm going to double check that. 12 divided by the 18 times 40.7 equaled 27 kilojoules. So guess what? I still haven't answered the question. The question says how much heat. So I need to take those two and add them together. And you're going to see there's an issue right away. What is it? You're right. We've got a unit issue. I happen to like kilojoules. So all of this work, 3.7, 27 is 30.8 kilojoules. For the Sig Fig Savvy, it's going to be 31 kilojoules because in honors we learn when you add, they have to match. That's a lot of work. Hopefully this works for you. Thanks.